Hostler here. I'm going to give you notes on the 7.2 lesson. And so in the 7.1 lesson, we introduced the idea of a quadratic function, a function that is x squared. The second difference is constant, where I'm multiplying two linear functions together. So today what we're going to talk about is the graph of that function, x squared. So it says complete the table of values and plot the points. So if I have x is -4 and I need to evaluate f of x, remember that just means I'm going to substitute -4 into x squared. When you do that, we need parentheses, -4 squared. That means I'm doing -4 times -4, which is a positive 16. So side note here, if in my calculator I type in -4 without parentheses, you're going to get -16 because your calculator is doing negative and then 4 times 4, which is a -16. But if I type in -4 in parentheses and square it, my calculator is including the negative when it's multiplying it by itself. When it's multiplying the 4 by itself, it's including that negative. Negative times negative is a positive. So there is a big difference when you type this in your calculator. You have to type this correctly because x squared means that I want to take -4 and I want to multiply it by itself, positive. I want to take -3 and I want to multiply it by itself, positive 9. -2 times -2, positive 4. 1, 0, 1, 4, 9, and 16. So just a heads up on that. If you tell me, but my calculator got -16, well, it's because you told your calculator not to include that negative when squaring. All right, so I'm going to go ahead and plot these points on my grid. And when I do that, I'm going to get -4, positive 16. So it's this point right here. I'm going to get -3, positive 9. So watch your scale on the y-axis. I get -2, positive 4. I get -1, 1. Watch your axis. 0, 0. And then I notice that there's this repeat in these y values, right? Like these y values repeat, and these y values repeat, and these y values repeat. So it looks like I have this like symmetric figure here. I'm going to connect those. I'm going to stick arrows at the end because I really could have plugged in more x values, but I would have had to make a bigger graph. Okay, so 2 says connect the points with a smooth curve. So we did that. And what shape is made by these points? Well, to me, it looks like I have this, I'll call it a U-shaped graph. And what's the lowest point on the graph? So the lowest point on this graph is here at 0, 0. I'm going to call that a couple of different things. So this is called the vertex. Let's label that. The vertex is the point where my function turns, right? I go from decreasing. I'm going to turn now upwards into increasing. So vertex is that turning point. This is also the minimum value or the minimum or lowest point on my graph. So just something to keep in mind. What is the domain of f? Well, when I talk about domain, I'm talking about all the x values that get graphed. And so when I look at this graph and I think about all the x values that could get graphed, technically I could substitute any x value into my function, right? If I go back up here to my function, there's no limit to the number I can put in there and square. I can put in any negative number and square it. I put in 0 and squared it. I could put in any positive number and square it. And so really my domain is all the numbers. And we say all real numbers. Any number that you can think of, I can type it in my calculator and square it. And so we say all real numbers is my domain. Any x value can be substituted in. What is the range? Now remember the range are the y values. And when I look at this graph, it looks to me like my range is limited. Right, like I graphed 0 and I graphed 1 and I graphed 4, but in between 2 got graphed and in between 3 got graphed and in between that the decimals all got graphed. But what I noticed is that nothing below 0 got graphed. Okay, and so my range is all y's greater than or equal to 0. You know, we're mathematicians and I don't feel like writing all those words because we're efficient, not lazy. And so I'm going to use my notation we've talked about, right? Y is greater than or equal to 0. I have a y value of 0 graphed, and all the numbers bigger than y were graphed, or bigger than 0 were graphed, but there were no numbers smaller than 0 graphed. So this is always going to be true for domain, always all real numbers. And my range is going to be based off of what's that lowest y value that got graphed in this case. All right, where is the function decreasing? All right, well, my function is decreasing here all the way to here. Stops decreasing here at 0. The thing is, I have this arrow, and so I don't really have a starting x spot where it's decreasing. There's just an ending spot. Okay, so where is f decreasing? Well, it's decreasing for all x smaller than or equal to, well, this x value here is 0, right? So for any x value that's to the, like if I were to color this in here, any x value to the left of 0, or all numbers that are smaller than 0, that's where my graph is decreasing. There's no starting x value here. And so instead of doing like in the past, we did like this, less than or equal to this, less than or equal to this, instead of that, I actually just need, there's no starting value, so I'm just going to do this. I'm going to say, well, it's all x values less than or equal to 0. There's no starting value. There's just an ending value, okay? Similarly, it says, where is f of x increasing? Okay, well, starting at 0, f of x is increasing. And again, that arrow means that I don't actually stop increasing in this case. There's no stopping x value for increasing. And so we're going to say, well, for all x greater than or equal to 0, for every x value on this side of 0, the x value of 0, my function's increasing. So again, I have a starting, I don't have a stopping. And so I only need one inequality for all the x's that are bigger than or equal to 0. My graph is moving upwards, okay? So that's the little difference here between when we did increase, decrease before for these segments, these starting and stopping segments of a line. For a quadratic, when I have that arrow extending, I either don't have a starting spot or I don't have an ending spot, okay? All right, let's keep going. Does f of x have a constant rate of change? Well, constant rate of change is slope. In other words, is the slope the same all the way through? And no. I mean, sometimes the graph is increasing, sometimes it's decreasing, so graph decreases. Need some room. Graph decreases, and then it increases, so it can't have the same slope if I have a negative slope and then a positive slope. Or we could say, no, it's not linear. Right? If I'm not linear, I don't have a constant slope. My slope would not be the same between every set of points. And then finally, 9 says, use a dashed line to draw the line of symmetry on the graph. Well, actually, I already drew the line of symmetry, but I have a lot of drawings here, and so I'm going to just erase this whole thing here and start nice and clean. All right, as a reminder, we had some points in here. I've graphed a lot of parabolas in my life, and so I should be pretty good at graphing these, although I missed that 9 in there. Okay, so here's that. I call it a parabola. We haven't named it yet. Here's that quadratic graph. And it says draw a dashed line through the symmetry of the graph. And as I was graphing this the first time, I said, well, it's interesting that these y values repeat. I have this symmetry. And so I feel like this symmetry line gets drawn right through this middle, this vertex that we called earlier, that turning point. Symmetry meaning that I'm like a mirror image on either side. I'm going to cut this graph right in half, okay? And it says, give two x values that have the same output. All right. Well, negative 2 and 2 have the same output of 4, or negative 3 and 3 have the same output of 9. We noticed that in our table before, okay? And so I can say, well, x equals negative 2, x equals 2. What do you notice about the location of these x values in relation to the line of symmetry? Well, they are the same distance away from this line of symmetry. They're the same distance away from the line of symmetry. If you notice, this output of 4 is 2 away on the left and it's 2 away on the right. The output of 9 is 3 away on the left and 3 away on the right. So I'm the same distance away on my graph from this axis of symmetry, and that's going to turn out to be a pretty big deal as well. All right, so let's flip this over and take some quick notes, and then you're going to see if you can give the check your understanding a try. I called this a parabola earlier, so let's just get this down. The graph of a quadratic function, so graph of a quadratic, Q-U-A-D-R-A-T-I-C, function is U-shaped. I'm going to put that in quotes, is U-shaped. It's called a parabola. So that's a fun word to say, parabola, okay? And something else that I just want to get down here is that the parent function which is the function we just graphed up above, y equals x squared, is the most basic quadratic function. Okay, and so that quadratic that we graphed on the other page, it looked something like this. That vertex was right at 0, 0. This is the most basic of the quadratic functions. We're going to be doing a lot with these quadratic functions. So I just want to go ahead and label some pieces. We say that this turning point right here is the vertex. We say that this line that goes through the middle, that's called the axis of symmetry instead of the line of symmetry. We call it the axis, very formal, axis of symmetry. That is actually a vertical line. It goes through the x value of 0. So remember, vertical lines are written as x equals, and they all have the same x value. All the points on that line have the same x value. So I'm going through the x value of 0. The domain is always all real numbers. And we've used this symbol before, this R with the double stem. And the range is going to be y is greater than or equal to 0 in this case. I only have y values that are positive or 0 for my basic function. All right, so your job is to use this basic function of x squared to answer some questions. And then you'll see in problem 4 that we do not have the same function as what's graphed on the front side, but I'm still asking you some questions about things like the vertex and where I'm increasing or decreasing the range. So you can practice identifying those things on a parabola that is not the parent function. You have questions, let me know.